find cyclonic winds.
Kansas, Oklahoma.
Find the cyclonic winds, for one. Or you can do what?
Just guess.
Check. Guessing is a bad thing. Check your pressure. Yeah, thank you. That's what I was trying to say. Do your contouring for isobars, because that should definitely pop out where your center of low pressure is. So if you look on here, over southern Kansas, northern Nebraska, in that general area, you can see how the winds are essentially going in a circle. Here's your low. Right in that general area. How do you identify the fronts? Differences in temperature. If you're looking for a cold front and you're doing your isotherm analysis, so you're trying isotherms on here, where you have a tight packing of your isotherms is generally where you're going to find a cold front. How else can you identify the cold front?
Converging winds? Converging winds.
Winds will generally converge along the fronts themselves. More so along cold fronts than warm fronts, inclusions and stuff like that. If you were to draw the low in here, notice here in Kansas, that's from Dodge City. What direction is the wind? The southwest Kansas on your map.
Southwest.
Northwesterly winds? Yes, coming from this direction. And what is it doing? We're generally south central Kansas. Southerly. You've got some sort of convergence right along there. Now, if you continue further along, you'll notice in the extreme upper northwest corner of the Texas Panhandle, you've got winds coming out of the northwest. In the center of the Panhandle, they're coming out of the southwest. Further down here over Clovis, Mexico, again, they come out of the northwest, and out in front of that, they're both coming from the southwest. So your front is draped, something like that. And ignore the cover. I'm just using a marker that actually works. There's your cold front. Remember when you're dealing with low pressures, generally, anything draped back to the west is always going to be a cold front. Anything to the east is always going to be a warm front. Unless you've got an occlusion and catching up and stuff like that. But for the most part, anytime you have a system that's setting up over Dakotas, Nebraska, Kansas, Colorado, Oklahoma, Texas, you're not going to have an occlusion because the system hasn't had enough time to develop an occlusion. So the only time you're going to see occluded fronts is by the time you get east of the Mississippi. So anytime you're doing map analysis, if you notice that you've got a system setting up west of the Mississippi, you will almost always not have any type of occlusion associated with it. You're going to have separate cold and warm fronts with the low pressure.
So it's east warm front, west cold fronts?
More southwest cold fronts. Cold fronts tend to drop down to the south and back to the west. Warm fronts are generally oriented in a more east-west direction.
So based on the station readings, how would you be able to tell where an occlusion was happening? Or would you?
You're not going to have an occlusion on this one.
But if you did, say like further east, how would you be able to tell from the differences in the station?
Usually what you would look for, find your main low. And in most cases, your main low is probably going to be somewhere up on the Great Lakes region or maybe even up into Canada. And you'll find that there's a secondary circulation somewhere down over the contiguous U.S. So you would have your main low up here with an occlusion down to the secondary low, and that's where your fronts are going to split out from here. In this case, there's obviously no evidence of a secondary low down here. You don't really see any type of swirling of winds as you get further north. What do you see as you go further north?
Jet stream?
You get into snow, there's definitely some precip up there. What else do you notice wind-wise?
They're all flying in the same direction.
Not really.
I can't really see from here.
What are they doing over Montana? What direction are the winds?
Or northwest.
Coming from the north. These would be northerly winds, north-northwest, generally going to the south. What are they doing in North Dakota? Yeah, kind of easterly winds, and then general vicinity. So again, you've got some sort of convergence there. You've probably got another type of front. In that instance, you've either got some sort of trough that's a little bit east of the mountains, or you've got a stationary front that's straight up along that area. Not necessarily. This could be the precursor for a secondary system that's starting to go. It's also an influence of the mountains as air's coming over it, it's forming that trough that you get. Where's the warm front, and how do you identify those? Warm fronts you can sometimes identify based on winds, but they tend to be a lot more diffuse than cold fronts. They're not going to be nearly as prominent in the wind field. So you can look in the wind field and see general areas of convergence to try to figure out where your warm front is. But what is a better indication of where it is?
Temperature and dew point are similar?
Temperature and dew point to some degree, but there's something even better than that.
Temperature gradient in between stations.
Even better than the temperature gradient.
Is where your freeze?
Precipitation, exactly. Look where you're reporting precip from your stations, and your warm front should be sitting either just in the precip or right on the edge of it to the south. Remember, as you get warm air that rides up and hits your warm front, it's going to go upward with the warm front, so it's going to produce precipitation out ahead of the warm front. Remember, your warm front's in the north. So that warm air is hitting the colder air, rising up over it, and you're getting precipitation out ahead of your warm front. So wherever you colored in your areas of precipitation, the warm front should be sitting something like that.
So the precipitation is always on top of the direction the cold fronts.
Typically to the north of it.
Yours extends over the Atlantic.
You could probably run the warm front further out, but it tends to get a little more diffuse as you go further east, especially once you hit the Appalachians. They tend to have the same effect that the Rockies do, where it tends to break up your surface pattern. It makes it a little more difficult to find the actual features on a surface map. All right? Anybody have any questions on how to identify the fronts and stuff?
I came in late with the cold front.
Something you have to do your notes.
What?
You shouldn't have come in late.
I didn't come in late because I wanted to.
That was the perfect timing.
You have to look at your winds. Generally, you have northerly winds behind it, with southwesterly winds or southerly winds out in front of it. And you also want to look and see where your temperature gradient is. That's the best way to find the cold fronts.